Welcome to BioWise with Aanchal. Now, today we are going to study chemistry. What in chemistry? Chemical bonding. Now, it's an interesting topic that will basically cover all your concepts related to chemical bonding, whether you're in class 9, whether you're in class 8, or whether you're in class 10. This is going to help you to understand chemical bonding, the basic concept of chemical bonding. Now, before coming into the actual topic, one request is there. Kindly subscribe the channel and then proceed with the class. Now, chemical bonding, if you talk about, it's a kind of bond formed between the two atoms. So, why do the atoms combine? Atoms combine to form a compound or a molecule of a compound or a molecule of an element. Now, if I say molecule of an element like hydrogen, chlorine, oxygen, nitrogen, these gases, the diatomic molecule, I hope you remember, or the molecule of a compound like carbon dioxide, water, calcium carbonate, and so on and so forth. Now, when I say the combination takes place, there is a bond formation takes place. So whenever there is a bond formation, there is a kind of sharing or exchange of electrons that is taking place. Because atom tends to lose the electron or gain the electron to attain a stable electronic configuration that we are studying since ages, right? Since 6th standard, not ages, 6th standard. Now, atoms combine with the other atom to attain a stable electronic configuration by complete their outermost shell, that is, complete their octet, right? Or that is your 2k shell wala 2 electrons I'm not taking into consideration right now. But whichever shell, the shell has to be complete, whether it is k with 2 or lmn with 8. Now, a chemical bond, if you have to define chemical bond, a chemical bond is a linkage or a force which acts between the two or more atoms to hold them together to form stable molecules or compounds. Now, chemical bonds are of two types. One is a strong bond and one is a weak bond. Now, strong bond example like ionic, covalent, coordinate, or metallic bonds, and weak bond includes hydrogen bonds or van der Waals interaction. Now, children, you have already studied about hydrogen bond in bio. When we were talking about the ascent of sap in standard 8 or even in standard 10. So, ascent of sap mein water moves in a continuous channel because there is a force of attraction between the water molecules and also the force of attraction between water and xylem. That is cohesive force and adhesive force. So, that is your hydrogen bond. Hydrogen bond is also there in DNA between the ATGC, that is your adenine, thymine, guanine, and cytosine. A double bond T and G triple bond C. I hope you remember, right? But still, if you have not studied standard 9 or 8 students, you'll study it later. Now, what is a valency? Before going into the concept, let us understand what is valency. Valency is the combining capacity of an element, of an atom. It tells us that how many electron is either lost or gained or shared while forming compounds in simple terms. So whatever is the combining capacity, like magnesium, magnesium has atomic number 12. So it has electronic configuration 282. So it has 2 electrons in the outermost shell, which it is very eager to give away so that it has a stable electronic configuration. Now, 2 becomes the valency of magnesium. Similarly, if I talk about oxygen, it has electronic configuration of 2 and 6. So, if I say 2 and 6, that means it requires 2 electrons to have an octet complete. So, it requires 2 electrons. Magnesium was giving away 2 electrons. So, both the cases, the valency is 2, right? So, we consider it as the amount of electron lost or gained or shared. Now, electrovalency, if you talk about, the number of electrons donated. Now, there was some sharing also we talked about in valency. But when we talk about electrovalency, we talk about complete donation. You give it completely and you take it completely. Once you give it away, it's completely given, it's not yours anymore. And once you receive the electrons, it is yours and you can have your octet complete. But while giving away the electrons or gaining the electrons, there are certain charges which develop on the atom. Reason is all atoms are electrically neutral. When I say electrically neutral, it means electrons are equal to protons. So when protons are not going to change, it is there in the nucleus. So when an atom is giving away the electrons, that is, electron is leaving the atom, the proton is going to exceed the electrons. So in that case, there is an acquisition of a positive charge. So all the metals have 1, 2, or 3 electron in the outermost orbit. So they have the tendency to give away the electrons and acquire a positive charge because of the excess of protons in the nucleus. So it forms cations. Similarly, the non-metals have around 5, 6, 7 electrons in the outermost orbit. So they have the tendency to acquire electrons and attain a stable electronic configuration. Now, once they take electrons, the electrons exceed the number of protons, and there is a negative charge developed on the atoms, and it becomes an anion. Understood? So, if I say ionic bonds and electrovalent bonds, there the bond is formed by the complete transfer of electrons. So, there is a possibility of formation of a, there is what possibility? There is a formation of a positive ion and a negative ion. Unlike charges attract each other, so they stay together as a compound. Understood? Now, what is ionic bond? The chemical bond formed between the two atoms by the transfer of one or more electrons from the atom of a metallic electropositive element. Electropositive element means metals as they tend to lose electron and acquire a positive charge. An electronegative element means they need electron, so they actually form anions. So metallic electropositive elements form cations and non-metallic electronegative elements form anions. Example: sodium chloride, magnesium chloride, calcium oxide. All these cases you see. If you say sodium chloride, sodium, that is 281, and chlorine, we will do this all children. We are doing this in the coming slides, okay? So here chlorine will acquire one electron, sodium will give away the electron. It will be Na plus Cl minus. Together they will form a compound called NaCl, your common salt. Similarly, magnesium, it requires it gives away two electrons. So Mg2 plus is formed. Now Mg2 plus, but chlorine requires only one. So two chlorine atoms are going to take one electron from the magnesium, and it forms a compound MgCl2. Similarly, calcium oxide, calcium also requires two electrons. That is, calcium has two electrons extra, 2882, and oxygen has 6, that is, two electrons deficient. So it forms O2 minus and calcium 2 plus, plus minus neutral. So they will form a compound together, right? So this is your electrovalent bond or ionic bond. When I talk about the covalent bonds, a covalent bond is formed when two nonmetals atoms share electrons. In this case, there is nobody to give completely and nobody is to take completely. So they tend to share. So any kind of mutual sharing is there. There we have the formation of a covalent bond. Water, you can see these are all nonmetals. So either it is a sharing between the nonmetals or there is a mutual sharing between the nonmetals. Okay, so it helps in the formation of covalent bond. When I say coordinate bond, all these bonds we are going to see example wise in the coming slides. I'm just giving you the proper definitions. You can pause the video, write the notes, and prepare a very good note for this unit. And the bond between the two atoms by sharing a pair of electron provided entirely by one of the combining atoms. In this case, we have a concept of lone pair. Now, for example, if I talk about oxygen, oxygen has got 6 electrons in the outermost orbit, correct? So when these electrons, suppose this electron participates in a bond formation, this also participates in the bond formation. This what is left is the lone pair. And this lone pair can be actually shared with a positively charged ions like hydrogen ion. Okay, we'll see how the bonds are formed. So always remember ammonium ion and uh, H3O plus, that is hydronium ion, are the good example of coordinate bonds or dative bonds. Always remember, metal plus non-metal is an ionic bond, that is electrovalent, give and take relationship. Non-metal, non-metal, that is covalent bond, that is sharing. Transfer of electrons completely is ionic. Sharing of electron is covalent. Number of electrons shared is equal to the number of bonds. Like H bond, this is a dash structure, children. So hydrogen, hydrogen, one electron pair is shared. Oxygen में two pairs are shared. Nitrogen में three pairs are shared. So that is why the number of bonds, that one bond represents one electron pair shared. Okay. Coming to the next, that is electron dot structure and dash structure. Now atoms combine by sharing electrons to become stable. We represent this by electron dot structure and dash structure. Always remember, when there are two atoms involved, use dot and cross so that you can differentiate between the atoms of the two, differentiate between the electrons of the two atoms. Is that clear? Now, electron dot structure, the valence electrons are represented as dot. Shared electrons are shown as the pair of dots, and lone pair is the pair of electron which is not participating in the bond formation. Understood? And dash structure is one shared pair of electron is denoted by a dash. Let us see. Now here the electron dot structure is not drawn. So this will do it together. Before that, one correction has to be done. Here, oxygen has got only 6. So this should not be there. Okay? This should not be there. Yes. Now let us talk about the um, now hydrogen. Now you know that hydrogen has got one electron in the outermost orbit. I'm doing it with the cross structure. I'm doing with the dot structure. Whichever way you're comfortable, you can draw. Now this is the other hydrogen. It also has got one electron in the outermost orbit. Now hydrogen has got K shell. K shell ka capacity is 2 electrons. Both will be stable if K shell has got 2 electrons. So what will happen? This hydrogen is going to share this electron and this hydrogen is going to share this electron. So finally they have one pair of electrons shared. So it has got one dash between the two atoms. So hydrogen forms H dash H. Understood? There is single covalent bond present. Similarly, when I talk about chlorine, now chlorine has got 7 electrons in the outermost orbit. Please write in the comment section what is the atomic number of chlorine. Atomic number of chlorine. So now chlorine has got 7 electrons in the outermost orbit. So 1, 2, 3, 4, 5, 6 and 7. Other chlorine also has got 7 electron. Since they're same atom, you can use the dots only, but I'm just trying to show you so that you remember, you understand how the things have to be made. Okay, so chlorine has got 7 electrons. Now this chlorine requires 8, so it will take this. This chlorine also requires 8, so it will take this. So in this case, you have the formation of one bond between the two chlorine atoms, forming a molecule, a diatomic molecule, that is Cl2. Here you have the formation of H2. Understood? Oxygen also, you can see the oxygen has got 6 electrons in the outermost orbit. Draw the structures, children. Draw these structures. You'll understand better. Now, if I say oxygen, oxygen has got, let me see whether it works or not. No, this is only better. Now, oxygen has got 6 electrons in the outermost orbit, right? 1, 2, 3, 4, 5, 6. And the other oxygen also has this 6 electron in the outermost orbit. 1, 2, 3, that is 3, 4, 5, 6. 6 plus 2 हो गया तुम्हारा 8 and this 6 plus 2 also 8. Now you can see there are two pairs of electron shared. So there are two bonds present between the oxygen atom. So oxygen forms O2. Understood? Nitrogen atomic number is 7. So 2 and 5. So it has got 3 electrons and 2, that is 5 electrons in the outermost orbit. The other nitrogen also has got 3 plus 2, that is 5 electrons in the outermost orbit. How many to be needed? How many electrons are needed to make 5, 8? 3 electrons. So this nitrogen is going to share these 3 electrons, and this nitrogen is also going to share these 3 electrons. 3 pairs of electrons are shared. So you have the 3 bond formation, that is N2. Now, when you write the dash structure, you don't have to show this electrons present here. You can simply show us like this. So oxygen, double bond, O. Nitrogen, triple bond, N. Understood? Similarly, when you talk about this chlorine and carbon, carbon 2, 4, atomic number 6. So it has got 4 electrons in the outermost orbit. And chlorine has got 7 electrons. So 1, 2, 3, 4, 5. You can fast forward if you want. Otherwise, you make it or with me. So that is easy for you to understand, because once you make it with me, then only you will understand it better, children. Now here also it needs 4 chlorine, because chlorine requires only 1 extra. Carbon has 4. So here chlorine will require C. Okay, so chlorine, so bond sharing, you can understand here 6, 7. So there are total 7 electrons. Now this chlorine will take 1 from here. This chlorine will take this. So all chlorine are satisfied with 8 electrons. What about the carbon? The carbon will take all the 4 1 electron from all the chlorine, making it 8. So you have the formation of CCl4, carbon tetrachloride. Similarly, you have the formation of methane. In this case, hydrogen ka 1 and carbon ka 1. So hydrogen will have 2. Similarly, ammonia, maybe you can see nitrogen has got 5 electrons in the outermost orbit. This is called the lone pair. Okay, this one, which is present on nitrogen, not participating in any bond formation, is called the lone pair. Understood? Is called the lone pair. Lone pair of electron. Clear? So how many lone pair? Now you tell me, this oxygen has how many lone pairs? So it has got 2 lone pairs, right? 2 lone pairs of electron. This oxygen has, right? Now your homework is to you write this and attach the photo in the comment section. Let me see how many of you can do it correctly. Now hydrogen has got 1 electron in the outermost orbit. Chlorine has got 7. Sharing is 1. Understood? Understood about the concept of lone pair? We'll come back to the lone pairs again in the coordinate bond. Because in coordinate bond, it's just giving. No sharing, no taking. It's just giving. Giving matlab to share, not hamesha ke liye. Okay? So this is how your covalent bonds are formed. Now let us go to the ionic bond. Ionic bond is formed by the complete transfer of electrons from one atom to the other. So formation of sodium chloride. So ionic bond is formed when an atom of a metal transfers one or more electron of an atom to the non-metal. Always remember. Now here there are different color of electron used. You don't use different color in the exam. Rather, instead of just use a cross. Instead of a dot, use cross. Always remember, electrons are represented as solid dots and or a cross, a small cross. Okay. Now, sodium electronic configuration is 281. Chlorine is 287. It is 1 electron rich and it is 1 electron deficient. So this 1 electron of sodium, okay, this 1 electron of sodium, okay, there is some error in the diagram, children. You can see this 2, it should be, there is a structure, there is an issue in the diagram. It should be here. 2, 2, okay, and 2. Okay, so this is not there, right? And there is one electron extra, 281, right? 281. Now this 281, this one electron will be transferred to the chlorine. Chlorine has got 2, 2, 2, and 2, 8. That is, again, here also there is an error. You have one more shell. In that shell, you should have 2 electrons. 2 electrons. So 2, 8, and 3, 3, 6, and 1, 7. Okay. So this is actually the complete orbital structure. We can simply write the dot structure. How is dot structure written? Like you have Na, outermost you have 1 electron, right? This 1 electron, and chlorine has got 7 electron. So 1, 2, 3, 4, 5, 6, and 7. This electron has to transfer here to make it 8. Understood. This will give you the Na plus ion will be formed here after the transfer, and you have the chlorine ion formed here. Opposite charges attract each other, so you have the formation of NaCl, common salt. Understood. Then you have, yes, you can see this. The opposite charges attract, and you have the formation of NaCl. Use dot and cross to depict electrons of different atoms. That will be easier for you. Now, coordinate bond, if I talk about, coordinate bond is the lone pair is shared. Now, you can see here, the lone pair is shared with it. So, for sharing, you give an symbol of arrow, the one which is sharing the electron with the other. Okay. Now, formation of a hydronium ion. Now, see this. This is very important. Now, when I say the formation of a hydronium ion is when you add acid to water, you have ionization of that is ionization of acid in water. In that case, the hydrogen ions are formed. Hydrogen ions combine with the water molecule to form hydronium ions. The hydronium ion may you see that water has got 2 lone pairs. In that, one lone pair is shared with the proton. So you can see the lone pair is shared with the proton. So you have the formation of a hydronium ion. Understood? Similarly, when you have the formation of ammonium ion, ammonia, this is a gas, NH3. So ammonia, after the formation of ammonia, this is all covalent bond. And this one is the lone pair, which is given to hydrogen. Okay. So now this is, I'll just draw and tell you. Okay, this is a bond. So this lone pair is actually given. This lone pair is given to hydrogen. And since this hydrogen is with a positive charge, the positive charge will retain there because the proton, there is a proton extra, right? So there is a charge developed. Here also, even this proton positive charge is coming, the electrons it is getting, but there is a proton extra. So therefore, there is a charge formed here. Understood? Is it clear? This is how the ammonia formation takes place. This is your coordinate bond. So the lone pair is shared. Hydrogen and nitrogen both are sharing the lone pair, but actually the lone pair belongs to the nitrogen only. Okay, so this is your coordinate bond. Okay. This is that is already shared now, so I don't have to draw it extra. This is sharing of electrons. from by the one of the atoms. Any doubt? Put it in the comment section, children. Okay. Moving to the next. That is, what is the difference between an ionic, covalent, or a coordinate compound? Now, when I talk about the ionic bond, usually hard crystalline solids at higher temperature, that is your um, okay, so you have 1 minute. Okay. Now, when you talk about ionic compounds are generally hard and crystalline solid. Reason is they have a very strong electrostatic force of attraction. Now, but for every property, I'm giving you a scientific reason. So you can reason out when any reasoning question is asked in the examination. All the covalent compounds are generally gases, liquid, or soft solid because they are held by covalent bonds, and they are also held by the weak intermolecular forces like van der Waals forces of interaction. And coordinate compounds can be also solid, liquid, and gas. They generally behave as the covalent compounds only. Okay, so molecular coordinate compounds generally have the properties similar to the covalent bonds. Melting point of ionic compound is high. Why it is high? Because they have a strong electrostatic force of attraction between the two oppositely charged ions. And melting point is generally low because only relative weak intermolecular force needs to be overcome when a molecular solid melts. Understood. Coordinate compounds contains discrete molecules and are held together by intermolecular forces. Hence, less energy is required for the coordinate compounds also. Boiling point is generally high for the ionic compounds and they generally decompose before boiling. Here the boiling point is low. Here also it's low. The reason is same, that is strong attraction between the ions. Electrical conductivity, if you talk about for ionic compounds do not conduct electricity in solid state. Like if you take only NaCl salt, there will be no electricity. But when you have it in aqueous solution or in a molten state, then obviously it is going to conduct electricity. The covalent and the coordinate compounds do not conduct electricity because there are no mobile or free ions present in it. However, the polar covalent compounds easily conduct electricity because they tend to ionize when they are added to water. So here polar molecules, they do conduct electricity when added to a liquid that is aqueous condition. Okay. Ions that are in case of solid, if you talk about, ions are present but are fixed in the position of a crystal lattice. So in solid state, they cannot conduct electricity. But in molten or aqueous state, you have the formation of free or mobile ions which help in the conduction of electricity. Electrical conductivity, we have already discussed, that is conducts electricity when molten or dissolved in water. Generally, the covalent and the coordinate compounds do not conduct electricity. Reason is same, that is your free and mobile ions. Volatility, that is generally the non-ionic compounds are non-volatile, but covalent compounds and the coordinate compounds are more volatile as compared to the ionic compounds, and generally their volatility varies greatly. Scientific reason क्या है? A strong electrostatic force of attraction here also. It holds the molecule very close. It does not allow it to evaporate in the air. But in case of covalent, there is a weak intermolecular force which tends the molecule to escape easily. Heat conduction, generally all the molecules, that is whether it is your ionic compounds, your covalent compounds or the coordinate compounds are poor conductor of electricity. Metals, metallic bond and all, metals, they are good conductor of heat and electricity. Although ions can vibrate and transfer energy, but they are not freely moving electrons as in metals. And covalent and coordinate, so they lack free electrons. Mostly ionic compounds are soluble in water. Water is a universal solvent. All the polar molecules and even ionic molecules, they go in water very easily. So many of the ionic compounds are soluble in water, but not all. Huh? You have to keep in mind, not all. Generally insoluble or sparingly soluble in water. Polar covalent substances may be soluble. Variable depends upon the polarity and the structure of compound. Now, water solubility के लिए water is a solvent which can dissolve almost everything. That is why it is called a universal solvent. Right. So, if ionic compounds may be, there are sparingly soluble ionic compounds also present. Scientific reason है polar water molecules can attract and separate ions through ion dipole attraction if hydration sufficiently compensate for lattice energy. That is the what to say, crystal lattice can be broken easily in water. Then only it will dissolve in water. Understood? Solubility is in the organic solvents. Generally, ionic compounds are insoluble in organic compounds or solvents. Polar covalent compounds are also insoluble in organic solvents, but rest of the non-polar compounds are all soluble. And even coordinate compounds may also dissolve. Okay. Ionization. Generally, the ionic compounds dissociates into ions. Right? Dissociates मतलब ions already exist. So they dissociate into ions. But covalent compound, they ionize in water basically. So they ionize, they form ions. Like for example, if I say water, water ionizes into H plus and OH minus ions. Correct. But if I say NaCl, NaCl dissociates into Na plus and Cl minus. So you have to understand the difference of ionization and dissociation. Okay, so dissociation into pre-existing ion in the molten or aqueous state generally do not dissociate into ions. They usually remain molecules when added to water. That is your covalent compounds and coordinate compounds. They remain as molecule. Okay, they do not dissociate, but they can ionize in certain solvents to form ions. Like if I add, what to say, high water, I gave you an example, right? The ion that is ionic lattice breaks apart and the already existing ions becomes free. Covalent molecules are not made up of pre-existing ions, so they normally remain molecular. Sugar and all, they remain molecular. Dissociation depends on whether the compound contains an ionic structure or not. For coordinate compound, it changes. Nature of reactions, usually ionic reactions, especially in aqueous solutions, are very fast. The covalent and the coordinate compounds reaction is a little bit slower. Reactions may involve, this is high children, this we are not studying now. Okay, so you have involved ligand formation, substitution, complex formation, oxidation reduction. That depends in the coordinate compound. Coordinate chemistry is coordinate compounds generally we're not studying about their reactions as such. In simple terms, NH4 plus or hydronium ions, you have seen the reaction. Like if you dissolve ammonia in water, you have the formation of NH4 plus and OH minus. Now, OH minus, a very good example, like water. From water, if you remove a proton, it becomes a hydroxide ion. Okay, so just remember water structure. In that water structure, remove hydrogen ion, H plus ion. So whatever is left behind forms a OH minus radical. Okay, the most important distinction, that is ionization versus dissociation. It's a very important concept. Now, dissociation, an ionic compound separates into ions that are already present in the compound, like Na plus, Na plus, and Cl minus in NaCl. And ionization is a neutral covalent compound molecule forms ions when it reacts or interacts with water, like HCl plus H2O. So H2O will form an hydronium ion, and you have chloride ion. First, you understand HCl will first dissociate into water as H plus and Cl minus. Now this H plus is going to the water to form a coordinate compound that is called hydronium ion. Okay, so ionic compound dissociates, covalent compound like acids and all, they ionize. Coordinate compound in which both electrons of the shared pair are donated by the same atoms, Therefore, simple molecular coordinate compounds generally show the property closer to the covalent compounds, not the ionic compounds. For example, ammonium, the N atom donates a lone pair to H plus to form a coordinate bond. However, the whole substance containing NH4 plus and an ionic can be and an anion can be an ionic bond. Thus, the physical property of coordination compounds cannot always be predicted as simply the presence of coordinate compound. Now, from here I get an example. I'll give you a compound, okay? I'll give you a compound. Like, for example, NH4Cl. This compound has actually all the three bonds. How it is possible? Now, you know that N will have three covalent bonds with hydrogen sharing, right? And it has lone pair that is donated to H to form a H plus, that is NH4 plus ammonium ion. So you have a coordinate bond, you have a covalent bond, and Cl forms a negative. So plus minus interaction, that is your cation anion interaction. So you have the ionic bond also. So in this case, you have all the three bonds in the same molecule. So it can be a good example. Give an example of a molecule which has all the three bonds. So ammonium chloride can give you a good example. Moving to our next important trick to remember, ions are already present in ionic compounds. Electrons are shared pair electrons are donated. Now, this we have already studied. You can take a screenshot if you want, but always remember they have high melting and boiling point. Others too don't have low. Conducts electricity only in molten and aqueous state. Generally, covalent and coordinate are bad conductors, except for the polar covalent compound. They can conduct electricity. Ionic compound dissociates and covalent compound ionizes. And here behavior depends. Okay. Now, what is the difference between a polar bond and a non-polar covalent bond? You know that covalent bond is always between the nonmetals. So, a covalent bond formed by sharing electrons unequally between the two atoms due to the difference in electronegativity. Electronegativity is how much it likes the electron. So, the more it likes the electron, it tries to attract the electron toward itself and keep. रिमेंबर जिसका प्रोटॉन हैवी होगा, जिसका न्यूक्लियस हैवी होगा, वो इलेक्ट्रॉन को अपनी तरफ खींच के रखेगा. करेक्ट. सो नाउ फॉर एग्जांपल इफ आई टॉक अबाउट HCl, you can see here. Now chlorine and hydrogen. So chlorine ka proton content is high in the nucleus. It is very electronegative. It loves electron. So what happens? It tends to, even the electron pair is shared here, this chlorine tends to have it closer to itself. So the bond formation becomes H, and you have this one. I will use blue color. Okay. I will use blue color here. So the chlorine, and it has all the electrons towards itself. So what happens? This hydrogen, though they are sharing the electrons, but still this hydrogen acquires a delta positive charge. Delta matlab very minute positive charge, and this requires a negative charge. This forms a polar covalent bond in which there are no cations and anions here. They are attracting the electron towards itself. So there is a slight negative charge on the atom, and it creates a polar molecule. Polar molecule means charge separation by a distance. So here you have a slight charge present on the hydrogen atom, positive charge, and chlorine mein you have negative charge. Similar cases you can see in all these cases, water, ammonia, hydrogen fluoride, sulfur dioxide, and all. But when you say equal sharing, mutual sharing is there. In this case, here it's all balanced in all four directions. Rest all is all mutual sharing. So nobody is strong enough to attract the electron towards itself. So it is no charge is developed. So this is a non-polar covalent compound. Understood? So with this, we completed with the chemical bonding concept. Any doubt is there, put it in the comment section. I'll get back to you. And For any other topic, if you want the video on, give it into the comment section. I'll make the video on that topic. Exams are coming, children. Kindly focus on your studies. I'm always there to help you with your studies. Put it in the comment section what you require next, and I'm there to help you. Be connected with BioWise with Aanchal. Subscribe the channel. That is very important. Yes, for me. So have a great day. Keep studying, keep learning, and keep growing, children. Thank you so much.